Good morning, everyone. Today I am going to present our project titled Data Driven Crime Analysis and Visualization for Public Safety. I am Ajay Sabri and I am going to represent my team behalf of Dharnesh and Dushyant. And our project internal guide is Dr. T. Rajsekharan. So, the main objective of our project is to improve the public safety by using artificial intelligence, deep learning, and data analytics techniques for crime detection and monitoring. Okay, from this, let's dive into the introduction part. So, in recent years, crime rates have increased due to rapid urbanization and population growth. At the same time, survival cameras and digital records are very high in amount to generate in everyday basis. However, the traditional monitoring system mainly depend on the manual observation, which is kind of difficult to identify the crime threats in effective manner. In order to overcome all this, we have developed a smart crime analysis that can automatically analyze the image and video, identify violent activities, provide instant alert to the user. So the introduction to this problem is mainly the crime prevention has become one of the most important challenges in the smart cities. So in order to attain this efficiently, we need to identify high risk locations, predicting the crime trends, monitoring survival footage continuously. So we do a interactive dashboard to analyze the crime data across temporal, spatial, and crime type dimensions, enabling identification of risk areas, optimized resource allocation, and enhanced strategy decision making for improved public safety. So therefore, these all can be done through deep learning and artificial intelligence. So the technologies used here are mainly Python. So coming to the problem statement. So in problem statement, rapid urbanization and population growth had led to significant rise in crime incidents, creating major challenges for law enforcement agency in maintaining public safety. So because of this, police department faced difficulties in identifying the uh, high risk zones and reporting and responding to it proactively. So in order to solve this issue, we developed a data driven crime analysis visualization system that can process large scale crime data to support smarter policing and improve public safety. So diving into the next slide, abstract. So our proposed system is a deep learning based aggressive behavior detection system using convolution networks, also called CNN. So the system analyzes the images and video streams to classify between aggressive and non-aggressive behavior. It performs effectively in conditions where the lighting is poor and the crowd density is poor. So in all these situations, we can uh, get a best result from it. When the violence is detected, an automated alert is sent to the mechanism, sent to the user or the authorities, saying that the crime has been detected in this particular region. So result and impact, the experimental results show the high accuracy and reliability. The system reduces the human dependencies and improves the response time, which is which is the intelligent surveillance. It is being used intelligently in surveillance areas such as schools and hospitals, transport hubs, and smart cities. So diving into the next slide, where the literature review. So in the literature review, we analyzed multiple research papers related to crime prediction and visualization. The first paper, which is being published in the International Journal of Computer Applications, it mainly focuses on real-time crime predicting using machine learning and random forest algorithms. So this is the paper which actually driven our interest in this topic. So speaking of the next paper, which is a data-driven crime prediction towards smart reduction strategies. So this second paper discusses environmental feature engineering and GIS heat map integration for identifying high risk zone. So this actually basically classifies the zones into two categories, which is of high risk and low risk, rather than just predicting a single count. So this can be done in a spatial, geographic spatial way using the real-time map. So the next paper we have used is data-driven innovations in crime prevention. So which is being published in ResearchGate publication. So the third paper actually highlights the problem-oriented policing and patrol route optimization techniques. So ensure that the visualization allows for stakeholder engagement, meaning city planners can use the data to improve street lighting or urban design in the high risk zone. So diving into the next paper, which is actually published in International Journal of Data Science and Analytics. The paper name is Crime Data Visualization Forecasting. So this paper actually uses the SARIMA models for seasonal crime forecasting and temporal trend visualization. So this actually identifies the crime zones during the specific months or the holidays, this peak times of the holidays. So in every time intervals, it actually fluctuates through 24 hours cycle. So these research paper works helped us in understanding the existing approaches and improve our proposed system. So diving into the next slide, the issues and challenges. While developing this system, several challenges were identified. These include incomplete and inconsistent crime data. So the data is not being very much in the clarity way. So the next challenge was the bias in historical data set, and which can lead to the unfair crime prediction. And the third one is the very important one, where the lack of real-time data, where the absence of data limits instant crime detection and response is not there, and the sensitive data is vulnerable to breaches if not properly protected. So the fourth one is legal and compliance challenges. Privacy and security concerns were very high. So these also very much big challenge for us to mitigate. And the next one is data integration challenge. So merging data from multiple agency and sources is complex and error prone. And the last one is model interoperability. Advanced analytical models can be difficult for officers to understand and trust. So it was way tough for us to make everyone to understand this application and to be used by every individual. So addressing these issues is important for building a reliable and accurate crime analysis system. So diving into the next slide, which is proposed work. Our proposed work consists of mainly four stages. First, we developed a CNN-based deep learning model using AlexNet and LeNet architecture for comparative performance evaluation. And then, secondly, pre-processing techniques such as resizing, normalizing, and data augmentation were applied to improve the model accuracy. So this actually brings out the better result out of it by doing all these techniques. And the third one is uploaded video are converted into frame by frame, and it is analyzed frame by frame individually using the trained CNN model. So this gives us more detail in the analysis part. So finally, we trained the model integrated into Django web applications where user can upload the images and videos for instant classification results for a quick decision making through, and it is a user friendly interface. So where we can upload this video, and these videos are being uh, normalized and resized and augmented frame by frame in order to get the better output. Diving into the architecture diagram, the diagram represents overall architecture of a system. The process starts with user uploaded images or the videos. So this input data, which is being fed into this input, undergoes pre-processing and frame extraction. So the processed images are passed into CNN model for classification, where each frame is analyzed frame by frame. So this is being resized and augmented, and it goes into this AlexNet or LeanNet. And the once the frame by frame analysis is done, finally the system displays violence or non-violence predictions, which is actually seen in the sixth diagram, which is classification. Violent means it actually points to is 1, non-violent means it actually points to 0. So before that, the feature extraction where the edges and the motion and the spatial patterns have been monitored, and the finally it triggers an alert notification to the user who is being handled the application through email or SMS timestamp long. Using with the timestamp, it actually sends the alert system. And finally, we can visualize all these things in a dashboard where there's chart or the snapshots or whatever things which is being overall done in a process, it can be shown in a dashboard. So diving into the important part where the system requirements and tools. So for implementing, we are used we used the following requirements and tools. So the hardware requirements includes the processor Intel i5 or higher, minimum of 8 GB RAM, and the storage should be of 40 GB minimum. So the software requirements include the operating system Windows or Linux, and the main programming language we work in is Python. So the next one is tool, which is we are using the Jupyter Notebook, and we are using many libraries inside it. So which is of NumPy, Pandas, and scikit-learn and Matplotlib, TensorFlow, and Django framework. We are using it for the front end part to show it. So diving into the another important uh, part is the modules. So our system mainly consists of two main modules. The first module is data preparation and model training. In this module, data sets are pre-processed, augmented, and used to train the CNN models. So the model focuses on preparing high quality input data and developing the deep learning classifier. The raw images and the videos are standardized through pre-processing and evaluation to improve robustness. The data set is divided into training, testing, subsets to enable effective learning and evaluation. CNN architectures such as AlexNet and LeanNet are implemented here using TensorFlow and Keras. Keras is mainly used here. So the next module is violence detection and system deployment, where the user upload the images or the videos using Django framework. So the process is here. It actually do it frame by frame, and each frame is being carefully seen through each and every scenes of the videos, and it gives the best output and effective output, and which shows the it is whether there is any violence or non-violence prediction in it. So this module applies the trained CNN module in real time detection. The system accepts the image and videos through a user-friendly Django web interface. So here the train module is integrated into Django interface for real-time prediction and monitoring. Once the violence activity is being predicted, the user actually gets a mail to his uh, Gmail account saying that the violence is being detected in this particular location. So onwards, jumping into this implementation screenshots. So here we are using violence and non-violence data sets. So as you can see, the one side of the photo is full of violence, and another side of the photo slide is full of non-violence. So with using all these data sets, we are feeding into the input part. So after that, this is the web page for crime analytics. This and this is a user login interface. So once this is done, and this is how the video is being. Yes, this is how the video is being. This is how the video is being done. So yeah, this is the implementation screenshot where crime alert dashboard is being seen here. And once the crime is being seen here, we send the alert system to the admin's email. And this is the last where we created our app AI-based crime analysis. So here we can see the chart and everything and where the violence is being acting, system architecture on flow. So these are the reference paper. Thank you.